Hey everybody, I hope that you're doing well. So this is section 2.5. It's going to build directly off of the skills that we have gained in 2.4. Now if you think about what we gained in 2.4, we learned how to graph inequalities, and we also learned how to write those graphs in interval notation. We learned other things, but those are the two main skills that we're going to use today. So we need to talk about two words before we can jump into today's lesson. The word and the word or. We kind of know what those mean. What does and typically mean? So let's just say that you are on your favorite dating app, and you are swiping through people, and you come to this guy, and he says he is rich and he is good looking. What does that mean since he has the word and in there? Well, if he's rich and good looking, that means both of those things have to be true, right? Both at the same time. And means both things have to be going on for him to be telling the truth. Okay? The fancy mathematical word for this is an intersection, where both things are. Okay? Other people think of this as an overlap. And you'll see why all of these words make sense in a little bit when we jump into examples. So that's what and means, right? Both things are going on. Both things are happening. Well, what does the word or mean? Well, or typically means, so if he says he's good looking or rich, he could be good looking, he could be rich, he could be both. But one of them, at least one of them, has to be going on. So one, the other, or both. Okay? The mathematical word for this one is a union. Doesn't make as much sense, so we won't use that as much. But anywhere that there is one or the other one or both. So or means anywhere anything's going on is fine, right? And means we need both things going on. Or means one or the other, or both things, but, you know. So that's what and or means. Let's see how we're going to use these today. We're going to do something called the three-line method. So what we're working with the three-line method is making more hardcore compound inequalities. So we're looking at compound inequalities that are more. So last time we did compound inequalities, and they were just those like these right here. Right, it was just stuck in between two numbers, but there are more combinations of things that can happen. So the more things that can happen, we need a more hardcore way of handling these. And so this textbook in the math department here chosen to use this thing called the three-line method. And so it all comes from the understanding of ands and ors. So let's actually take a look at some examples. We're going to do an and and an or with the same example, okay? So and an or. So here is how the three-line method works. We actually need three lines. Okay? And they're just three number lines. Okay? And we're going to make sure they're lined up. And we're going to literally graph these two graphs. This is x is greater than 3. That's what the top graph is for. X is, less than or equal to 3. My bad. You can't read. We're going to graph on the top graph, x is less than or equal to 3. On the bottom graph, we're going to, not the bottom, the middle one here. On the middle graph, we're going to graph x is greater than negative 1. And then the bottom graph will be our answer, and we'll talk about that in a second, okay? Now the point here is that these three number lines are lined up. So we're only comparing the two numbers. So actually, let me write this another way first and show you the lazy way we write it. So we need to make sure that these are lined up. Okay, so for instance, if I have x equals 3 right here and negative 1 here, I'm going to have these lined up at the same spots all the way through. So make sure these number lines are lined up where 3's are at all these and negative 1's are at all of these. Usually what we do is just lazily draw one big line through it and put the negative 1 in the 3. Notice you have to be careful and make sure you put these the correct way. I don't want 3 over here if this is the number line, because 3 is not smaller than negative 1. It needs to go on the right side. So I have these in the correct order because these are just number lines. So we already know how to graph, right? So let's graph the first one, less than or equal to 3. So let's go to 3. Less than or equal to means I'm shading in this direction, just like we shaded last class. And it is an or equal to, so a square bracket. Okay, so we've shaded that one. On the second line, we will graph or shade the second inequality. It tells us x is greater than -1. So let's go to -1 on the number line. Greater than is a parenthesis, right? And greater than is this direction. Alright. So is everybody with me so far? There's no new skills here. If you wanted to look at this another way, all we have done, don't write this, but all we've done is graphed one of these where x is less than or equal to 3. We've graphed the other one, x is greater than -1. And what we're going to do now is combine these two together to get the answer. Okay, and so let me see, maybe I can represent this really nicely visually. So the first thing, before we do this, this is what I strongly suggest all my students do. Circle the word so that you have to pay attention to what word it is. This is an and write the word and. Write the word on the third graph, the third line, because that's going to be our answer. And what did and mean? And means that both things have to be going on at the same time. Okay? Or another way of thinking of this is overlap. So let me show you. Let's see if I can visually show you a good representation of what this is. So if I were to take the top line, let me do these in different colors. The top line looks like that, right? And the bottom line, or the middle graph, it looks like that. Oop, let me do this. I said in a different color and I totally spazzed. Let me try this again. Oop, not yellow. Wouldn't be able to see that very well. And the idea is, if I could just smush them together. Whoop. Try to get them grouped together. There we go. If I would just smush them together, bring them down on top of each other, where do they overlap at? Do you see that? Where do they overlap? Where is green and blue happening? Oh, in between -1 and 3. So that is an and is where is overlap happening? So now you can't actually take your line on your paper and squish it down like this. So we visually just say, okay, if we were to smush this down, where do they overlap? Where are they both happening? Are both of these lines shaded on the left? No. In the middle here, are both of them shaded? Absolutely. So since both of them are shaded in the middle here, just like when I smushed my lines together, wherever they both have graph, wherever they both overlap, that is our answer spot. Then over on this side over here, are they both shaded? Not the top one, the bottom one, the second one is. So wherever they both are shaded is what we will shade for an and, because an and means both or overlap. Now notice I have this -1 and this 3 here. I need symbols of some sort, so I always just look up and see whatever I used. I used a parenthesis on the -1, so I'm going to use a parenthesis right here. On the 3, look up and see, oh, on the 3 I have a square bracket, so I will use a square bracket right there. Okay, so now that we have gotten our answer graph here on the 3-line method, I can write my interval notation for my final answer. So let's see, the interval notation is going to be, we start shading at -1, and we finish shading at 3. And of course we use the same end symbols that we used on the line. Alright, awesome. So this is a little weird. It's our first example. But the 3-line method is just you graph one on the top line, you graph the other one on the middle line, and then the bottom line you have to use the word to put these two together. So putting these two together, we're looking for anywhere where they both happen or where they overlap. They overlap in the middle, and so that is That is our answer. Okay, let's do an OR now. Or maybe it would be good to do more ands and then come back and get ORs. I don't know. I don't know what would be better. Let's go ahead and do the OR. Okay, so once again, we're going to do a 3-line method. And so let me get us 3 number lines. And we need to line these up at 3 and -1. So let me put those in there. -1 is a smaller number, so it goes on the left. 3 goes here. And we're just going to graph x is less than or equal to 3 and x is greater than -1. And I know how to graph these already. Let's see, x is less than or equal to 3. It's going to be a square bracket, and less than is this way. This one is going to be a parenthesis, and greater than -1 is this way. So now, what's the only difference in these two problems? Notice I use the same inequalities. The difference is in the word. So the word here is OR. So that's what I'm going to write on my 3rd number line. Now remember what OR means. OR meant if it had one or the other or both. So what OR means, let's see if I can show you again in a similar way. OR means that if I were to smush these two shaded graphs together, anywhere that I have, oh, it linked them together. Let's see if I can ungroup them. And ungroup them into a lot of pieces. But anyways, anywhere that you see green line is going to be in our graph. Okay, so let me show you what I mean by this. So over here on the left, is there any shading? Is either one of them shaded? Yeah, this one's shaded. Right here, you see this? So that's going to be part of our answer. Okay, and then we look in the middle. Are either one of them shaded? Yeah, both of them are. That's definitely one of them at least, right? So we shade there. And over on the right side, are either one of these shaded? Yeah, this one is. So an OR means anywhere that you have shading up top is going to come down into your answer. So you see that these are very different final answers because of the OR and the AND. Now let's see if we can do this interval notation. So where does our shading start? At an arrow. And so that is -infinity, comma. Where does our shading end? Add another arrow. That is positive infinity. And infinities always get parentheses. Alright. So this OR runs from -infinity to positive infinity. Think about what that means though. It's kind of like saying you can ride this ride at the fair if you are taller than 3 feet or less than 4 feet. Everybody would be included in that, right? Because if you're not taller than 3 feet, you're definitely less than 4 feet. Or if you're not less than 4 feet, you're definitely taller than 3 feet. So that's what this is saying. When you use an OR, sometimes ORs are more inclusive, ANDs are more restrictive. Okay, let's look at some more examples. Another example of the same two numbers, but with an AND and an OR. I guess I don't have to cover it up this time. Less than 3, greater than 4. We're going to do an AND and an OR. So let's put 3 lines down. We'll do the AND first again. Let's see, let's put them in the right order. 3 is smaller than 4, so 3 goes here, 4 goes here. And what we will do is graph them. X is less than 3, X is greater than 4. Alright, so let's graph X is less than 3. Let's go to 3. That's going to be a parenthesis, right? And less than is this direction. Okay? That's not bad. Alright, X is greater than 4. So let's find 4. It'll be a parenthesis, and greater than is this direction. Alright, what word do we have? We have an AND. Now, AND means both or overlap. Do these two lines, these two shaded lines overlap? So if I were to take these and try to move one up and down, do they overlap? Do they cross anywhere? No, they don't. So there's nowhere that they overlap. So we do not graph anything down here because there is no part of a solution. So this one's a no solution, or you can simply write the empty set, which is a 0 with a big slash through it. Or you could call it, let me write the empty set. Empty set. Okay? So there's our empty set. So this is, think about this though logically. This is like the same example I did with the riding the roller coaster at the fair. See, for kind of the opposite, it's like saying the only people that are allowed on this ride have to be less than 3 feet and taller than 4 feet at the same time. That's impossible, right? We can't be less than 3 and bigger than 4 at the same time, so there's no solution. Okay. Let's see how this same graph would look with an OR, though. Okay. So with an OR, this would be completely different. Ands and ORs have completely different meanings to them. 3 and 4. So let's see. Let's graph. What is it? X is less than 3. So go to the 3. Less than's this way. We should already know how to graph this since we're just using the same one, but this is greater than 4. So go to 4, parenthesis, greater than. So now what OR means is anywhere that I have shading, you are allowed. So look over here. To the left of 3, I have shading. So that is in my answer. Do I have any shading in the middle besides that stray mark that I just randomly added? Now I don't have any shading here and I don't have any shading here, so I'm going to leave it out of my answer. To the right of 4, do I have any shading here? No. Do I have shading here? Yeah, so I do have some shading. So if there's at least one bit of shading up top in the top 2 graphs, it comes down in the answer for OR. I forgot to circle and write my word, but we were doing an OR. Okay, this is kind of like saying you can ride the elevator if you were, not the elevator, oh my goodness, roller coaster, if you were less than 3 or taller than 4. So this only leaves people out that are in between the 3 and 4. But it includes these people. Because it is an OR, notice the huge difference in ands and ORs. ORs allow more, ands are really restrictive. Okay? And means they have to overlap. OR means anywhere that you have shading on the top 2 is included in the final answer. Oh, we did not write the interval notation yet. So if you look and you trace left to right like I've taught you, this starts at negative infinity and then it stops at 3. But there's another section of it, so there's 2 intervals that I have to include. Starts at 4 and goes to positive infinity. And what we do is when there's more than one section, when more than one interval in our answer, we put this symbol in between them, a big U, that means union. That means both of these belong together. This is just 2 intervals, and these 2 intervals make up our answer. Alright, so let's look at one more combination of things that can happen. Once again, same examples of, notice the numbers are the same, but one's an ands and one's an OR. If you haven't noticed, I'm giving you every combination of these inequalities that you can have. I had them both pointing in, I had them both pointing out. Now I'm going to have them pointing in the same direction. So let's see, what do I have? 1 and a 4. Alright, so let's get some color here. Let's graph the first one. X is greater than or equal to 1. So let's see, go to 1, greater than or equal to, so that'd be a square bracket. And greater than's this direction. Alright, excellent. Let's graph the second one. X is greater than 4. So greater than, that's a parenthesis, right? And we shade in this direction. Alright, now let's pay close attention. So what is the word? It is an and. Whoops. Let's put our and down here. Now, and means where do these things overlap? Do they overlap here? No. Do they overlap here? No. They overlap over here. Now, because we started our answer at 4, we have to look up and get the symbol off of 4, which happens to be in parentheses. So our interval notation would be 4 to infinity. So and, once again, is restrictive. Okay, it makes the smaller of the two sets. Let's look at how or would be with the same example. So let's see, what do I got? 1 and 4. Alright, so x is greater than or equal to 1. It's a bracket, and greater than or equal to is this direction. X is greater than 4. That's a parenthesis, and it shades in this direction. And then finally, what word do we have? We have the word or. And so or means anywhere that I have shading up top, I'm going to have on my answer. So over here, do I have any shading right here? No. How about in the middle? Oh yeah, I got some shading in the middle. So that will be in my answer. How about to the right of number 4? Yeah, I got shading on both of them. That's fine. So that will be in my answer. So my answer starts at 1, so look up and grab the same symbol. Okay. And so let's see. So interval notation would be from 1 to infinity. Okay. So there we go. So notice this gives you a bigger group of people that are allowed in the club, because or is more inviting, more inclusive, and is more restricting. So it's kind of like if we say that to be in the club, you have to be over the age of 1 and make more than $4,000 a year. If I say and, you have to meet both of those requirements. If I say or, if you just meet one of those requirements, you're in the club. So that's kind of what this is like. All right. Now that's all I have for you today. We were just introducing this 3-line method. So what I just want you to notice, what we're able to do is we're able to put together two inequalities with an and or an or and create a compound inequality that is more intense than the ones we were looking at yesterday or last class time. We're able to combine things that are more extreme, and we get these extreme answers like empty set, no answer, or the entire real line from -1 to 1. So you can get a lot of interesting stuff. And all this comes from is putting together two inequalities with a word and or. We're going to use this next lesson in a more an interesting way. So make sure you kind of soak this up and understand what we're talking about, okay? Have an awesome day. I'll talk to you guys later.